So we're going to try factoring by the AC method. So we're going to be factoring 8x squared negative 10x plus 3. So our A value is going to be 8, our B value is negative 10, and our C value is 3. So for the AC method, we're going to multiply A times C, which is going to be 24, and then 2 factors of 24, then multiply to 24 and add to negative 10 are negative 12 and 2. So x negative 12, x plus 2. And now we're just going to switch the signs, and it's going to be x 12 and x negative 2. So these are going to be our 2 factors. So now we're going to factor by finding the GCF of the expression. So here's our expression, 2x to the third minus 8x. So we see that there is 3x's here and 1x there, so we can factor one of those out. So we're going to say 2x, and then we're going to do x squared, because there's 3 x's, minus 4, because 8 divided by 2 is 4. And now we're just going to factor that out even a little bit more. So 2x, and then there's 2 more x's right there, so x plus 2 and x minus 2 for to make up 4. So that's going to be it. That's our answer right there.
For our first equation, we're going to want to be solving it using the quadratic equation, but the equation that we're going to be solving is this lucky little lady right here. So I notice how it's equal to 0. It's got to be equal to 0 to solve it. Okay, so first things first, we're going to find our A, our B, and our C, just because it makes my life easier in a second, and your life too. So for A, we look right here in front of this guy, and we see that there's nothing, so it's a 1. Oh, sorry, it's a 1. Okay, we look here, and we see that that's a 12, so 12 for B, and then we look at our C position, and we see that that's a 32. Okay, now we know that quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Now, Mia, can I borrow your calculator? Okay, we're going to plug our values in that we found over here into this. So now we just rewrite it. So 12 is positive, but it's negative. So we're going to switch that sign, and we're going to have negative 12. Okay, negative 12 plus or minus the square root of positive 12, because it's just b, not negative 12. B squared minus 4 times a, which is 1, times c, which is 32, and that's over 2 times a, which is 1. So just 2. Okay, so now we're going to plug that lovely number into the calculator, and you don't have to do it this way, but the way that I find is most helpful to do it is I plug everything under the square root in first. So I do 12 squared minus 4 times 1 times 32, and that is 16. And then you can plug that into the square root symbol, and of course it'll be 4. And then I rewrite it as negative 12 plus or minus 4 over 2. Okay, and now I can just think these through. So they're separate problems. So negative 12 plus 4 over 2, and negative 12 minus 4 over 2. Okay, and we know negative 12 plus 4 is, of course, going to be negative 8. And negative 8 divided by 2 is negative 4. So that's one of our zeros. And then over here, we have negative 12 minus 4, which gives us negative 16 divided by 2, negative 8, which is our other 0. So the answers are negative 4 and negative 8. X plus 3 squared plus 4. And actually, what we're going to do here is we're going to graph this guy. So we look and we see that our x value is going to be equal to 1. And we know this because this x right here just has well, okay, sorry, I'm not making sense even to myself. So let's go ahead and draw our little graph over here, just so that we can kind of get some semblance of graphing going on for everyone's happiness. Okay, so we look at our problem up here. I'm going to scratch that for now. This guy is very important, okay? So we have y equals 1/2 x plus 3 squared plus 4. And so let's pretend, and we're going to plug 1 in for that x. So now we have 1/2 1 plus 3 squared plus 4, okay? So then we can simplify that down, obviously, to y equals 4 squared plus 4, and then 4 squared, or 1/2. 1/2, 16, because, 4 squared is 16, plus 4, and so now we have y equals -8 plus 4, so y equals -4. Okay, so we can keep that in mind, and if we know that y equals -4, that will come in handy for us later. Okay, so then we can also figure out and graph this thing. Okay, so our vertex is going to be -3, because you look at him and then you swap the sign, -3 and then 4. So we can go ahead and graph him. Okay, so -3, 1, 2, 3, 1, 2, 3, 4. Okay, and notice how we have, oh my gosh, I'm sorry, I've been writing positive 1/2. It's -1/2. That's why it was negative down here. I apologize. I was just doing it in my head. So we have this -1/2, and because it's negative, it means that our parabola is going to open down. And so we can do a fun little trick, and we just go 1 down and 1 over. So down 1, over 1. So you're right here, down 1, over 1. You're right here, and then down 2, over 2. Down 2, over 2. And then we can, just draw him out. And there is our beautiful parabola with a vertex at -3, 4. Okay, so I'm going to erase all this. And then we have another graphing problem, which should be pretty easy peasy. Okay, so here we go. I'll just increase the size a little bit so I can do this quicker for you. Okay, and then back on down. Okie doke. So our next problem is y. Oh, that might be a little too thick. Sorry. Our next problem is y equals x squared plus 4x plus 3. Make it a little smaller. Okay, so we have that, and we can essentially say 0, because y in this scenario, we can just say 0, equals, so let's solve this down. Sorry, I'm going insane. Let's solve this down. So we have x squared plus 4x plus 3, and we can solve this using quadratic formula. So our b is 4, and our a is 1, and our c is 3, and then -b plus or minus the square root of b squared minus 4 times a times c over 2a. And then we plug in our actual values, which is going to be -4 plus or minus the square root of 4 squared minus 4 times 1 times 3 over 2. And so then we plug in everything under the square root symbol. And then that will give us -4 times 1 times 3. That gives us 4, and then of course the square root of 4 is just 2. So now we can rewrite this as oh my gosh, sorry guys, -4 plus or minus 2 over 2, and -4 plus 2 is -2, and -2 divided by 2 is -1, so one of them is -1, and -4 minus 2 is -6. -6 divided by 2 is -3. So -3 is our other. And then I'm just going to erase all this because it's getting in the way. So -1 and -3, and we need to keep those in mind, right? So now we can rewrite this problem in a way that's going to make our lives so very much easier. And we can just rewrite it because we know we have that -1. And that negative 3, we can rewrite it as x minus 1 and x minus 3 equals 0. Okay, now what we can do here is draw out our beautiful graph. Okay, boom, 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 bing, bang, bang, boom, bing, bang. Okay, so now that we have our graph out, we can create our table, and then we can go ahead and graph it. So right now we know that 3, because we look up here, and this number b is always going to be the y-intercept. So we know 3, 0, because that's where it would intercept y. And then we can have 0 and 1, negative 1, 2, 3, 0, and 4, 3. And then we can just graph these points. So 0, 3, 0, 1, 2, 3, boom. And then 1, 0, 1, 0, 2, negative 1, 3, 0. Looks like we're going back up, and then 4, 3. Okay, and because this over here is positive, that's plus, it means our parabola is going to open up. So this is our graphed equation. If we want to look at the date-night method for simplifying radicals, we can just use this lovely little example problem. So he's negative 7 square root of 540 x squared y to the 5th. Okay? Okay, so we look at that, and then we can simplify them using the date-night method. And that's the couples go out on dates, singles stay home, right? So we look at it, and we can go ahead and make a factor tree out of him. So obviously 540 can be divided by 2. And so 540 divided by 2 is 270. So you can do 2 and 270. And 270 can clearly be divided by 10, which can be divided by 2 and 5. And 270 is divided by 10 is just 27. Okay, and then that can be 3 and 7, which are also prime numbers. So 2 and 2, that's one couple we have here. And then 5, 3, and 7. They aren't couples. Oh no, this is so sad. And then we also have our x cubed, which is a couple. And our x to the 5th, which is 2 couples and one little single dude who nobody loves. Okay, so we can look at that and we can say, okay, so we have this negative 7 already outside the radical, and now we have this 2 that we're going to bring out. So times 2, and then also we're going to bring out this, You can edit out the awkward silence. They just something different than me, and I'm worried. 2 times 5 is 10. 3 times 7 is not 27. 9 times 3. Okay. I have led you guys astray, and I am so very sorry. I just see a 7, and I think this was a 7. Okay, so it's 9 times 3, that's 27, and then that's 3 and 3. So now we have a couple of 3s, and then one lonely single dying alone 3, excuse me. So times 3, and then we leave everything else inside of here that we don't want or need or love, which would just be that leftover 3, that 5. So 3 times 5 is 15, so we can just write that in there. Yeah, 3 times 5 is 15, so we write that in there, and then we have 1 y left over, so 15y. And then negative 7 times 2 is negative 14. And, okay, and then in the end, negative 7 times 2 times 3 is just negative 42. So negative 42, 15y. That'll be our date night answer.
Okay, let's move on to complex numbers. So let's start with adding complex numbers. So I'm just gonna make a example problem right here. So, sorry. Okay, so when adding things with different variables, you need to group the similar numbers together. So we know that 8 and 4 are both by themselves. They have no variables, so that means that we can add them together. So 8 plus 4 equals 12. And 7i plus 3i, they both have I as a variable, which means we can add them. So 7 plus 3 is 10, so be 10i. So the answer would be 12 plus 10i. Okay, this one's a little bit more complicated, but we can do it. Basically, all you have to do is FOIL. So let's start with 5 and negative 8. 5 times negative 8 is negative 40. Then 5 times 5i equals 25i. Then negative 3i times negative 8 would be 16i. Oh, wait, sorry. My fault. It's not 16. Oops. That is not 16. That would be 24i. And then negative 3i times negative 3i times positive 5i would be negative 15i squared. Now, before we do any more simplifying, I think we should get rid of this I squared because you can simplify it. So we know that I squared is equal to negative 1. So we can do negative 15 times negative 1, which is just equal to 15. So now let's just simplify everything else. Negative 40 plus 15 is equal to 65. So let me erase this because it's kind of in the way. Let's just put 65 here. And then 25i plus 24i is equal to 49i plus 65. That'll be your answer. Pretty simple. Let's go to division now. So, okay. Actually, let me put it on top. That'll be easier. Divided by 8 minus 2i. So you can never have the variable of I below the division bar in the denominator. So what you need to do is you need to, balance it out by multiplying the problem that you're trying to solve by the denominator. So you would do times 8 minus 2i over 8 minus 2i. And then you would get, let me just move everything over. Okay, now let's simplify. So you would have 3 times 8 equals 24. Then 3 times negative 2i is negative 6i. 4i times 8 equals 32i. And then 4i and negative 2i is equal to negative 8i squared. But we know that we can't have the I squared, so this is going to turn into positive 8. And I'm just going to do that now so I don't have to do that later. And then do the next part. We do the denominator now. So 8 times 8 equals 64. Then 8 times negative 2i is equal to negative 16i. You can do that twice because the other problem is the same. And then negative 2i times negative 2i would be positive 4i squared. But let's get rid of it. Get rid of the I squared. So now it would change to negative 4. Now, keep simplifying. 24 plus 8 is equal to, hold on. Yeah, okay. 24 plus 8 is equal to 32. So it'd be 32. And then negative 6 plus 32 is equal to 26. So it'd be plus 26i.
And then 64 minus 4 is equal to 60. Negative 16i minus 16i is equal to 32. So it would be negative 32i. Now, sorry, that looks like an 8. Now, to get this down even further, we are going to divide everything by 2 because that works in this situation. So 32 divided by 2 is 16. 26 divided by 2 is 13i. 60 divided by 2 is 30. And 32i, or negative 32i, is equal to negative 16i. And that is going to be your answer. It's a pretty long process, but it's pretty simple. So, let's move to the next one. Okay. So, we are going to be doing I to the higher power. And how can we figure that out, you ask? So I have this little trick where I can make a table. So let's make that little table up here. That will help us later. I'm going to have 4 columns, sorry. Now we are going to have I to the first power, I to the second power, I to the third power, and I to the fourth. So these are going to represent the ways that we can figure out what I is equal to. So we know that I is equal to I. We know that I squared is equal to negative 1. And then I times negative 1 is negative I. And negative 1 times negative 1 is equal to 1. That's how we figure out what they're equal to. But whenever we use the trick where we divide whatever number that the exponent is divided by 4, we get some kind of decimal. And the decimal place determines what it is equal to. So if you just put the exponent over 4 up here, so 1 divided by 1 over 4 is 0.25. 2 over 4, as in the exponent, is 0.5. 3 over 4 is 0.75, and 4 over 4 is 1. So that is how you do it. So let's just get an example problem so that you understand. We can do I to the 45th. Now all you have to do is take the exponent and divide it by 4. And 45 divided by 4 is equal to 11.25. Now, if we look at this chart over here, we see that the 0.25 is equal to I. So I to the 45th is equal to I. And that is your answer. Okay, let's keep going. Okay. So let's do a kind of quadratic formula kind of problem. So let me get x squared plus 4x plus 5 equals 0. So how would we solve this? There are 3 ways. We can do the factoring method. We can do completing the square. We can do quadratic formula. Let's do quadratic formula. So let's write out our actual formula first. I'm just going to write it over here. So it'll be x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So let's keep that in mind right now as we do this. So negative b in this option, or in this equation, would be 4. So it'd be negative 4 plus or minus the square root of 4 squared. We know that's 16. Minus 4 times a, which is 1 in this case, times c, which is 5, over 2a, and a is 1, so it would just be over 2. So let's simplify this area here. I'm just going to bring it down. So it'd be negative 4 plus or minus the square root of 16 minus 20. Now this involves a problem here because this would equal negative 4, and you can't have a negative inside the square root. So whenever you have a negative number, just take out the negative and put it as I. So you would have negative 4 plus or minus I times the square root of 4 divided by 2. But you also need to take out the extra, I don't know exactly how to word this, but the extra stuff. So let's just use the day and night method. So 4 is an even number, so you can split it into 2. So 2 and 2, so that means it is a pair. So we can bring that outside. So it'd be negative 4 plus or minus 4I over 2. And then just to finish this problem, you just divide by 2. This is a very lucky problem where you can divide, or else you just have to keep it there. That's kind of ugly. Doesn't really look that good, but in this problem you can, which is very nice. So it would be negative 2 plus or minus 2I. That would be your answer.